Hello guys, welcome to i-tutor Academy. In today's session, we will start with UNIT4 MMPC005. It's measures of variation and skewness. So let's see the objectives of this chapter. After going through this unit, you will learn the concept and significance of measuring variability, the concept of absolute and relative variation, the computation of several measures of variation such as the range, quartile deviation, average deviation and standard deviation, and also their coefficients. The concept of skewness and its importance, the computation of coefficient skewness. And introduction of this unit is here in the first structure, and the significance of measuring variation, properties of a good measure of variation, absolute and relative measures of variation, range, quartile deviation, average deviation, standard deviation, coefficient of variation, skewness, relative skewness, summary, keywords, self-assessment exercise, and there is further reading also section is there. And let's begin with the introduction part. In this previous unit, we were concerned with various measures that are used to provide a single representative value of a given set of data. This single value alone cannot adequately describe a set of data. Therefore, this unit we shall study two more important characteristics of a distribution. First, we shall discuss the concept of variation and later the concept of skewness. A measure of variation describes the spread or scattering of the individual values around the central value. To illustrate the concept of variation, let us consider the data given below. So here is data based. You just go through this and it will more clear. And next is significance of measuring variation. Measuring variation is significant for some of the following purposes. Measuring variability determines the reliability of an average by pointing out as to how far an average is representative of the entire data. Another purpose of measuring variability is to determine the nature and cause variation in order to control the variation itself, and measures of variation enable comparison of two or more distributions with regard to their variability. Measuring variation is of great importance to advanced statistical analysis. For example, sampling or statistical inference is essentially a problem in measuring variability. Next is properties of a good measure of variation. A good measure of variation should possess, if as far as possible, the same properties as those of a good measure of central tendency. Following are some of the well-known measure of variation which provide a numerical index of the variability of the given data. Range is there, average or mean deviation, quartile deviation or semi-quartile, interquartile range, and standard deviation. And next is absolute and relative measure of variation. Measure of variation may be either absolute or relative. Measure of absolute variation are expressed in terms of the original data. In case the two set of data are expressed in different unit of measurement, then the absolute measures of variation are not comparable. In such cases, measures of relative variation should be used. The other type of comparison for which measures or relative variation are used involve the comparison between two set of data having the same unit of measurement but with different means. We shall now consider in turn each of the four measure of variation. Range. The range is defined as the difference between the highest, that is numerically largest value, and the lowest, numerically smallest value in a set of data. So here is the symbols. And in this example, the variation is nil in case of daily sales for fame A. The variation is small in case of fame B, and variation is small large in case of a fame C. The range is very easy to calculate and it gives us some idea about the variability of the data. However, the range is a crude measure of variation since it uses only two extreme values. The concept of range is extensively used in statistical quality control. Range is helpful in studying the variations in the prices of shares and debentures and other commodities that are very sensitive to price changes from one period to another. For meteorological department, the range is a good indicator for weather forecast. For group data, the range may be approximated as the difference between the upper limit of the largest class and the lower limit of the smallest class. So activity based on here, activity A, activity B is here, so you just go through it, try to do that. And the next is quartile deviation. The quartile deviation, also known as semi-interquartile range, is computed by taking the average of the difference between the third quartile and the first quartile. The symbol is, this can be written as QD, that is Q3 minus Q1 divided by 2. The Q1 is the first quartile and Q3 is the third quartile. And following illustration also here. So based on this illustration, you can practice this and it will more easy for your understanding. And activity C also here, try to do it. And this is for today's session. And next section of unit 4 we will discuss on next video. In between, any doubts you can contact us. For more MBA videos, you just do like, share and subscribe our channel. And thank you for your support.
i-tutor Academy presents Ignou Mba complete syllabus coverage classes for individual students, semester-wise subject with online and flexible timing. For more details, contact on +916 238 21785.